Today we're going to go over some of the basics of polynomial functions, such as how to name them, identify degree, number of terms, and behavior, and the maximum number of turns that could happen when we graph. So first we're going to start off with identifying the standard form. In order to do the standard form of a polynomial, you do want to make sure that you arrange your terms in order by your exponent, and it will be a descending order. So we're going to start with the largest exponent, which is the 7x to the fourth. Also make sure that as you rearrange your terms, whatever sign is in front of that term is going to move with that term. Since this 7x to the fourth is positive, I do not need to write it at the beginning of my polynomial, but if it was negative, I would need to put a negative sign there. The next term in order would be the positive 3x cubed, and the next term would be positive 9x squared, and the final term would be positive 2. Now, when it comes time to name it by degree, first you must identify the degree of the polynomial. The degree is going to be the largest exponent, and by rearranging things in standard form, it makes it very easy to find the degree of the polynomial. So this is a degree of 4, which means that it is quartic. Naming this polynomial by the number of terms, it has 4 terms. The special names would be for monomials, binomials, and trinomials, but a 4-term polynomial, we're just going to call it a quartic polynomial with 4 terms. As far as end behavior, there's only 2 possibilities for end behavior. If your degree is even, it's going to follow the same end behavior as a parabola would. Think back to positive parabolas. If you have a positive quadratic function, both ends are going to be headed to positive infinity. If you have a negative quadratic function, then both ends would be headed to negative infinity. So, like I said, since this is even, it's going to follow that same identical end behavior. Even and positive means that both the left side of the graph and the right side of the graph are headed to positive infinity. Maximum number of terms. The maximum number of terms can be found by subtracting 1 from the degree. Now, it's a maximum number. So this polynomial could have 3 turns, and by a turn, I mean that it changes direction. So it could look possibly like this, or it might only have 1 turn and look just like a quadratic function. All right, let's go through number 2 just to do this one more time. Put the polynomial into standard form. This particular polynomial is already in standard form, so I will just write it exactly as it is. Name it by degree and number of terms. The degree is 5, which makes it quintic, and it has 3 terms, which makes it a trinomial. So this will be a quintic trinomial. As far as end behavior, the end behavior of all odd degrees will be the same as a line. If you think about a positive line, the left side of the line would be headed to negative infinity, but the right side would be headed to positive infinity. A negative line, linear equation, the left side would be headed to positive infinity and the right would be negative infinity. So this is an odd function that is negative, so it's going to follow this same trend. The left side will be headed to positive infinity and the right side to negative infinity. Maximum number of turns is 1 less than the degree, so it is a 4. In example 3, we're just asked to simplify. This is an addition or subtraction problem, and it does have parentheses in it. So what I usually tell my students is to look in front of the parentheses to see if there is a number or a sign that needs to be distributed. If there is not, then the parentheses are unnecessary and we can drop them. So in this second set of parentheses right here, there is a negative sign which does need to be distributed before we remove the parentheses. So this gives me negative 3m to the fourth, negative 6m cubed, and negative 5m. This plus sign is not going to change the signs of anything behind it. So again, this parentheses is unnecessary and I can just write down the terms without it. Now that you've removed all the parentheses, it is time to group things that are alike. These terms are alike if they have the same variable raised to the same exponent. So I can put 4m to the fourth, negative 3m to the fourth, and 2m to the fourth together. And that gives me 3m to the fourth. A lot of times, once I have used the terms, I will cross them out. Next, I'm going to combine negative 6m cubed with positive 3m cubed, and that gives me negative 3m cubed. The m squared doesn't have anything to combine with, so I will just write it down, positive m squared, and the negative 5m also does not have anything to combine with. So this is my final answer. Always double check and make sure that your final answer is written in standard form, descending order by your exponent. When we multiply a binomial times a trinomial, we're going to use double distribution. We'll take the first term and distribute it to all three terms. That will give me positive 64n cubed, negative 64n squared, and negative 32n. Now we're going to go back. We'll take the second term, negative 3, and distribute it to all three terms. As you are writing down the answers, I like to stack the similar terms on top of each other. So negative 3 times 8n squared is negative 24n squared, which means I will put it here with the other n squared term. Negative 3 times negative 8n is positive 24n, and negative 3 times negative 4 is positive 12. Now it's time to combine the like terms. And since I have stacked them, I can see easily that I will combine these terms together. My final answer is 64n cubed, negative 88n squared, negative 8n plus 12. In this final example, we can do a triple distribution, but sometimes people will drop a term or forget to multiply something. So I do encourage you to find some sort of organization method to make sure that you've multiplied everything together. One method is the box method. You don't have to use this. There's several others, but this is a good way to organize your answer. Since we have 3 terms times 3 terms, I'll create a 3 by 3 box. These first 3 terms will be written down the side of the box. You don't have to write plus signs, but you do need to write the negative. These next 3 terms will be written across the top of the box. As you can see, this is just triple distribution. I'm going to take the first term and I'm going to multiply it times all 3 terms across the top. And when I fill in these 3 boxes, I know that I have completed multiplication for this first term. I get 2v to the fourth, 4v cubed, negative 12v squared. Now I'm going to take 4v and multiply it times all 3 terms across the top. That gives me 4v cubed, 8v squared, and negative 24v. Finally, I will take the negative 8 and multiply it times all 3 terms across the top. Negative 8v squared, negative 16v, and positive 48. Once you've done this, the box does organize the like terms in a nice fashion. The diagonals will be where you will find things that are alike and you can combine them. So my final answer, I'll write down my 2v to the fourth first. Then I will combine the 4v cubed and 4v cubed to give me 8v cubed. I'll combine these 3v squareds. The negative 8 and positive 8 cancel, so I'm left with negative 12v squared. When you combine your v's, you get negative 40v. And the 48 doesn't combine with anything, so I will write down positive 48.